This is General Tin. This is the third of our tin techniques, the third and last of our tin techniques. So if you have done sections 4 and 11, you have already completed the first two of our throwing in numbers techniques. You have done Vita, you have done Nidus, and as I said, General Tin is the third and last of these tin techniques. Now, General Tin has some things in common with these other two tin techniques. Obviously, we are throwing in numbers here and using arithmetic rather than algebra. So at its core, yes, we're doing the same thing as we were in Vita and Nidus, but we are going to be doing things in a slightly different way. And one of the other tricky things about General Tin is that there is no consistent tip-off clue as there was for Vita and Nidus. Vita and Nidus, it was almost always very easy to determine that we could use those techniques. With General Tin, yes, you will generally have numbers in the answer choices, but instead of the question asking for a single variable or unknown, like questions that are amenable to Nidus do, the question will probably be asking for some kind of a relationship between two or more quantities. So if you take a look at the first page of the Nidus technique, there's a box that explains what single variable questions look like and a box that explains what relationship questions look like. And with General Tin, you're going to want to look for those relationship questions. So basically, if you go through this flow chart on a question, you may be able to determine whether General Tin is an option for you. So if you ask yourself what's in the answers, if there's variables, obviously you're using Vita. If there are numbers, remember you have to ask yourself, is the question asking for a single, that's what the S is in Nidus, for a single variable like X or Y or M, or is the question asking for some kind of relationship, in which case you may be able to use General Tin. So again, if the question is asking for a single variable or unknown, you're probably going with Nidus. If not, you're going with General Tin. Now, the General Tin steps, interestingly enough, are almost identical to the Vita steps. You are going to list all variables or unknowns. Let's go ahead and write that down. List all variables / unknowns. You are going to throw in easy numbers. By the way, so far we are writing exactly what we wrote in the Vita steps. Now, one big difference between General Tin and Vita, and something that makes General Tin a lot easier to use than Vita, is this. You do not need to avoid 0 and 1. In fact, in General Tin, use whatever you want as long as it's allowed by the question. Use whatever you want as long as it's allowed by the question. So if the question doesn't give you any stipulations about what your variables values can be, if they give you completely free reign, you can use whatever you want. You can use 0, you can use negatives, you could use fractions, whatever you want. And then last is to solve using your numbers. Solve using your numbers. Now, notice there is no step 4 here like there was in Vita. In Vita, step 4 was to check all of the answer choices. In other words, to convert all the answers from variables to numbers. Well, in General Tin, you already have numbers in the answer, so there's no conversion that needs to take place. So let's take a look at number 34, which, as is often the case, we start with something that's fairly simple that you may very well be able to do using algebra, but we're going to do this with General Tin to get a feel for the technique. Now, this question says if a equals b plus 2, then b minus a to the fourth equals. So they're asking for this, so we're going to circle that. We are going to do the steps that we just wrote above. We're going to first list our variables. We're going to then throw in numbers. Now, I'm actually going to sort of demonstrate one of the things I just said, that we can use whatever the hell we want. So I'm throwing in a equals 2. That means b has to equal 0. 0 plus 2 equals 2. So b has to be 0. So check out what happens here. Now we have 0 minus 2 in parentheses, which is just negative 2. Negative 2 to the fourth equals 16. And look at that, we are done. And if you don't trust that that was all on the up and up, if you're suspicious and wondering what the heck just happened and how you got that answer so easily, one of the things you can do is you can try a different number. Let's say we try a equals 5. That means b is going to equal 3. 3 plus 2 is 5. So in parentheses we get 3 minus 5 to the fourth, and again that is negative 2 to the fourth, and that equals 16. So no matter what we use, whether we use 0, whether we use 5 and 3, it doesn't matter. We're going to get the answer that we need to get. So that is a quick, simple introduction to General Tin, and that's pretty much all there is to it. You're just throwing in some numbers and you're producing one of the answer choices. Now, on the next page of the General Tin section, what we're going to do is we're going to run through several more examples, and we are going to see some variations of the technique, some slightly different ways you will apply the technique, or hints for applying the technique on certain types of questions that are asking for certain things. For instance, on number 11, they are asking you for a fractional part. There is a slight hint that you might want to know on such questions. Let's go ahead and read this all the way through. Let's work this one together. So VAT1, VAT2, and VAT3, when full, each hold the same amount of water. At present time, VAT1 is 5/6 full, VAT2 is 1/12 full, VAT3 is 1/3 full. Water will be transferred, blah, 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 blah. After the transfer, each of the 3 vats, so each what fraction full? That's what the question is asking. So a lot of phrases, a lot of little ins and outs here. So let's take this one step at a time. But before we do, we're going to go ahead and write down a note in the left-hand column pertaining to, as I said, questions that ask you for fractional parts. So on fractional part questions. Okay, so again, when the question is asking you for a fractional part, what fraction full, what fraction of the students were seniors, so on and so forth. If you're general tinning on one of these questions, what you want to do is throw in the largest answer choice denominator for the total. Throw in the largest answer choice denominator for your total. Now, I know that it might not be obvious what that means, so let's start working through this and you'll see what I mean. So the answer choices, you've got a 3, 6, 9, 8, and 12. So there's your largest denominator. So what we're going to do is we are going to make that the total capacity of the vats. So we're going to say VAT 1, VAT 2, and VAT 3, and we're going to say they have a capacity of 12, and that's 12 cups or gallons, or the units don't really matter, but let's say gallons. So when full, they each hold the same amount of water. Okay, well, the amount of water that we're going to say they hold is 12 gallons. At present time, VAT 1 is 5/6 full. Well, we are going to do, so let's do present time. 5/6 of 12 is 10, and that can, and for a lot of you, should be done in the calculator. 5/6 of 12, we go in the calculator and we get 10. So at present time, VAT 1 has 10 gallons in it. Next phrase says that vat 2 is 1/12 full, so we are going to do 1/12 of 12 and get 1, and vat 3 is 1/3 full, and 1/3 of 12 is 4. So at present time, this 10, 1, and 4, this is the amount of gallons that each of these vats have. Now what we're going to do is we're going to take all of this water and we're going to transfer it between the vats so that we divide the water evenly through through all 3 vats. That's what this next phrase says. Water will be transferred so that each of the 3 vats contains the same amount. Well, there's 15 gallons right now. So if we put the same amount in each of these 3 vats, each of them is going to get 5 gallons. And now finally, the question is asking, what fraction full will each of the 3 vats be? Well, this guy is 5 out of its total capacity 12, 5 out of 12, 5 out of 12. That should be our answer. So we get E. Now, there's a couple of notes. 1, why did we choose the largest answer choice denominator? The reason that we chose the largest answer choice denominator is because that largest answer choice denominator will tend to play very nicely with the fractions and more specifically the denominators that we were given in the question. If we were to choose a random number here like 5, let's say we said vat 1 has a capacity of 5. Well, 5/6 of 5, okay, so this would be our capacity. At present time, this would be 5/6 of 5, which is 25/6. We can use this number. It's fine. We have a calculator. We could go through the question using these ugly numbers. The thing is, though, that if we use 12, the largest answer choice denominator, the numbers in this present row are all going to work out to be really nice, neat, whole numbers. So again, you can use whatever you want. It's just a good practice to, on a fractional part question, look through the answer choices and pick the largest denominator. Now, the other note is it is purely coincidental that the answer choice, E, that has the largest denominator turned out to be the right answer to this question. You could, we could pretend that there was another answer that was, let's say, we have to make this, let's say 7 out of 24, and then that would be the largest denominator in the answer choices, and we would use the 24, and if you use the 24, what ends up happening is you get a capacity of 24, 24, 24. Vat 1 is 1/12 full. Vat 1 is 5/6 full. Well, 5/6 of 24 is, what is that going to be? It is going to be 5/6 of 24. And again, we can just do this in the calculator. It's going to be 20. And then the vat 2, 1/12 of 24 is 2. Vat 3, 1/3 of 24 is 8. So there are 22 and 8, which is 30 gallons in all 3. If we split 30 among the 3, we get 10, 10, and 10. Well, watch what happens. If there are 10 gallons in each of these vats, and that is out of a capacity of 24, then each of these is 10/24 full, and guess what 10/24 reduces to? It reduces to 5/12. And again, calculator will do that for you. So even if there had been another answer choice with a larger denominator, that's fine. We would just use that other number, but we would see that the answer would still come out to be E. Next question. So just as in VITA, we talked about dependent variables. Remember that the word equal means there's an equal sign here. So this is really an equation that they're giving us. A equals 2b plus 3c minus 5. Well, we do have to be careful on a general tin question that has dependent variables. We have to be very careful to make sure that our numbers work. So here's what we're going to do. I'm going to use a little T-chart here. So again, the note on this question just deals with dependent variables and the need to make sure that we're using numbers that actually satisfy the dependent situation described in the question. So let's go ahead and read through this whole question. Let A equal 2b plus 3c minus 5. What happens to the value of A if the value of B decreases by 1 and C increases by 2? So this is what they're asking. They're asking what happens to the value of A. So again, I'm going to go ahead, since I know I'm going to have to throw in multiple numbers for each of these variables, I'm going to make a t-chart so I don't have to keep listing A equals, B equals, C equals, and then A equals, B equals, C equals again. I don't want to have to do that multiple times, so t-chart's going to work nicely here. 3 columns, 1 A, 1 B, 1 C. I'm going to start off with B and C. If you have seen the nidus video or done the nidus section, you know that we often should start with the variables with more junk around them. B and C have coefficients. A is bare. So we are going to start with B and C. Let's make B 2, and we're going to get cute here, and we're going to make C 0. Remember, on general tin questions, it's perfectly fine to use 0 or 1, so let's do it. So this is A is going to equal 4 plus 0 minus 5. So A is going to equal -1. Again, use your calculator if you need to, but 4 plus 0 minus 5 is -1. Now, they tell us that B decreases by 1, so our new B is 1, 2 decreased by 1, and the value of C increases by 2, so C is now 2. So we're going to calculate A again. 2B with our new B is going to be 2, that's 2 times 1, plus 3 times C, which is 6, minus 5. Okay, so I'm just throwing our new B and our new C in for B and C, and what I'm going to get is 2 plus 6, which is 8 minus 5, which is 3. So they were asking what happened to the value of A, and it should be that it increased by 4. That is indeed what they're asking, and that is indeed the right answer. If you want to try this again with different numbers, go ahead and do it. Obviously, you just have to be careful to plug everything in correctly and do your arithmetic calculations correctly, but every time you will see that A increases by 4 no matter what numbers you use. That was number 49. Now number 57. Whenever W is an integer greater than 1, log blah blah blah. So here's a good example where you don't really have to have any knowledge of logarithms whatsoever. If you have a slight knowledge of how your calculator works to deal with logarithms, actually let me use, yeah, we can use this. The calculator will do all of this work for you as long as you know that in your math menu you have something called log base down at the bottom, somewhere near the bottom of your math menu. So again, that's math, and you can stay in the math menu, and actually if you hit up, you'll get there most likely a little bit quicker. You're looking for something called log base on most of these modern TI graphing calculators. You will see it there, and what log base does for you is it allows you to punch in all of the values really nicely and simply, your base and the number that you are taking a log of. So if we just say that W equals, let's say W equals 2. So what this is going to become is log base 2 of 2 squared over 2 to the 6. And I'm not even going to do that calculation. I'm going to go right up in here, and I'm going to hit the 2 there. And then I am actually going to go, you don't have to do it this way, but to make this nice and neat, I'm going to hit alpha, and then this F1 key, which is the Y equals key. So again, I hit alpha and F1, and I'm going to punch in a little numerator over denominator thingamajiggy here, and I'm going to go 2 squared, and in the denominator I'm going to do 2 to the 6th, and I'm going to hit enter, and I'm going to get -4, and I am done. That is it. So again, really the only knowledge of logarithms that you have to do a question like this with general tin is knowing that your calculator will do a log base calculation as we just did. In case I haven't mentioned it already, remember there is obviously no need to check the other answers when we're general tinning, because only one answer can equal -4. This is not like Vita where we could get doubles. There is no way to get doubles when we're doing general tin. So that is how we would deal with a logarithm question. Now on number 60, yet another variation of general tin in which we are given some ingredients and need to know what those ingredients mean. So let's go ahead and write this down. Let's write when given a range of inputs and asked to find a maximum or minimum output, we're going to write down throw in the boundaries of the input ranges. So go ahead and get that written down. And again, I know it might not be completely clear what that means just yet, but we're going to apply it on this question and hopefully it'll become clear. So let's read through the question. When -3 is less than x is less than 4 and y is blah, 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 what is the least possible value for x minus y? So let's take a look at those ingredients I was talking about. So we have the range of inputs right here. So there's a range of inputs for x and a range of inputs for y. And we are being asked for, in this case, a minimum output. We're asking for, or the question is asking for, the least possible value for the expression x minus y. What a lot of students do on this question is they fool around in between the -3 and the 4 and the -1 and the 2. In other words, they'll make x equal to 1 or x equal to 0, and they'll make y equal to 0 or y equal to 1.5. And while that's not necessarily wrong, it is not the most efficient way to tackle a question like this. Here's the most efficient way to tackle a question like this. Again, since I'm going to be throwing in multiple values for each of these variables and determining multiple results for x minus y, I'm going to make a little t-chart here. And this is what I mean by throwing in the boundaries. What we're going to do is we're going to pair the low x with the low y, the low x with the high y, the high x with the low y, and the high x with the high y. In other words, we're going to do -3 for x, and we're going to do -1 for y, so that's low, low, and then -3 for x, 2 for y, that's low, high, and then we're going to do 4 for x and -1 for y, that's high, low, and then we're going to do 4 and 2, that's high, high, and watch what happens. So -3 minus -1 is -2, and again, all of this stuff can be done in your calculator. -3 minus 2 is -5, 4 minus -1 is 5, 4 minus 2 is 2, and what we have just done is we have fleshed out, by focusing on our boundaries or our endpoints, we have fleshed out both the minimum value and the maximum value. And in this case, they were asking us for the minimum value. The minimum value is -5, and we're done. So again, when they give us these input ranges and they're asking us to maximize or minimize the output, it is a good idea to focus on the endpoints or boundaries of the input ranges. Usually that will pretty quickly and clearly produce the maximum and minimum values that you need. That is it for General Tin. So again, just remember that General Tin is a lot like VITA in the way that we solve it. Biggest difference is that we have numbers in the answer choices rather than variables, as we do in VITA, and we don't have to do that step number 4 that we did in VITA, where we had to convert the answer choices to numbers. In General Tin, we list our variables, we throw in our numbers, and we get a result, and we pick it, and we move on. Pretty simple technique. Look for opportunities to use it, and happy tinning.